Welcome back to another coding challenge with Mubashir. Today we have an interesting problem that involves finding the median of two sorted arrays. So without any further delay, let us dive into the problem. Here we are given two sorted arrays, nums1 and nums2, with both of them having different sizes m and n respectively. Our task is to find the median of the merged sorted arrays from these two arrays. Additionally, we need to ensure that the overall runtime complexity of our solution is order of log m plus n. The problem that we are tackling today is a very fascinating challenge with practical applications, especially in data analysis. Before we dive into the solution, let's understand the significance of finding the median and the impact of input size on complexity. The median provides the balanced measure of central tendency, crucial for understanding the data distribution. As we explore this problem, keep in mind that the size of our input arrays plays a key role in shaping our approach. Our ultimate goal is to achieve a time complexity of order of log m plus n. We'll be adopting a non-destructive approach, meaning our solution won't modify the input arrays. This is a common requirement in many scenarios. The significance of achieving order of log m plus n time complexity is clear. It ensures our solution scales efficiently, even for larger datasets. We also need to keep in mind that handling the edge cases is essential. We need our algorithm to gracefully handle solutions like empty arrays, cases where both arrays have identical elements. The provided constraints guide us, preventing issues like overflow or underflow. To merge two sorted arrays while maintaining the sorted order, we'll compare elements and select the smaller one at each step. Efficiency is key, and we'll optimize the merging process using two pointers to traverse the array. Determining the median efficiently involves considerations based on whether the total number of elements is even or odd. Achieving order of log m plus n time complexity is not just a goal, it's a necessity for scalability. Our strategy will revolve around the logarithmic efficiency. We will explore the binary search approach, a powerful technique for efficiently finding the median. The role of partitioning comes into play here, ensuring that elements on one side are smaller and on the other side are larger. With the possibility of input arrays having different lengths, we will discuss how to handle this scenario. Our strategy involves adjusting the binary search based on the length differences, aiming for a partition point that balances sizes on both sides. To ensure the correctness of our solution, we will cover a variety of test cases, including arrays of different lengths and edge cases like empty arrays. Additionally, we will discuss how our algorithm performs with very large inputs, validating its scalability within the given constraints. To better understand the problem, let's go through a couple of examples. The first example, we have nums1, which is 1 and 3, nums2, which equals 2. Our output will be 2. As the merged array is 1, 2 and 3, the median is 2. For example 2, we have nums1 is equal to 1 and 2, nums2 is equal to 3 and 4. Our output will be 2.5. As we can see, the merged array is 1, 2, 3 and 4. And the median is 2 plus 3 by 2, which equals 2.5. These examples give us a good idea of the expected output and help us understand the problem even better. Alright, now that we have a clear understanding of the problem statement, the given examples and the constraints, let's move on to solving this coding challenge. Stay tuned for the next part, where we'll break down the problem, come up with a solution together. If you are ready, let's get coding. This block of the code ensures that nums1 is the smaller array between the two. If not, it solves the arrays. It initializes the variables x and y with the lengths of nums1 and nums2 respectively. Additionally, it sets the initial values for the binary search range, low and high. This section performs a binary search to find the correct partition point in the smaller array nums1. It calculates the partition point for both arrays and ensures that the elements on the left and the right side of the partitions meet certain conditions. This block checks if the current partition points are at the correct position. If they are, it calculates and returns the median based on whether the total number of elements is even or odd. These lines adjust the partition points if they are not at the correct position. If max x is greater than min y, it means the partition point, partition x, is too far to the right. So it adjusts high to move the partition point to the left. Otherwise, it adjusts low to move the partition point to the right. This code essentially implements a binary search algorithm to find the correct partition points in two sorted arrays, aiming to divide the combined arrays into two parts such that elements on the left are smaller than or equal to elements on the right. The median is then calculated based on these partition points. Now that we have completed the code, let us see how it performs in real-life scenario. Let us run. As you can see, the test cases was accepted for both the example cases. Now let's see how it performs for all the test cases. Let us submit. As you can see, it was also accepted for all the test cases and got a very optimized solution. We have beaten over 93% of the users who have provided the solution with Python. In conclusion, we have explored a Python solution for finding the median of two sorted arrays. The algorithm cleverly uses binary search to efficiently locate the correct partition points, ensuring a balanced division between the left and the right sides of the combined arrays. Understanding and implementing such algorithms is crucial in solving complex problems efficiently. I hope you have found this explanation helpful. If you have any questions or suggestions for future videos, feel free to drop them in the comments below. Don't forget to hit the like button if you found this video insightful. Share it with others who might benefit, and subscribe for more contents on coding, algorithm, and programming. Your support is truly appreciated. And as always, if you have any questions or if there is any specific topic you would like to cover in the future videos, let me know in the comments. Thank you for watching and happy coding.